All right, good morning, everyone. So one thing I hope you all had a nice weekend. And one thing I want to note is that your fourth test is going to be this Sunday, Monday. All right, so it's going to come up soon. I had told you the fourth test and the fifth test only covered 2 chapters, so we turned through them really quick. So we'll go through the second part, the second chapter that will be associated with your organics, and you'll have your organics test this weekend. Oh, excuse me. My daughter had like a regression and woke me up probably 8 times last night. So if I'm a little sleepy, that's what's going on. So let's go ahead and check out chapter 12. So chapter 11 was all on like the really basic simple organics, right? So alkanes, alkenes, alkynes, those with some branches or substituents, accessories, and then we finished off with the benzene ring. And remember, the benzene ring is 6 carbons. We'll just draw it while we're talking about it. The benzene ring is 6 carbons. That has 3 double bonds that sort of oscillate. So this double bond kind of will rotate into this spot, and this will rotate into this spot, and this will rotate into this spot. So a lot of times these are drawn, the benzene rings are drawn like this with a circle in the center. Okay. If I was to have an accessory like this, we could call this methyl benzene. We don't need to call it 1-methylbenzene again because we assume that that is carbon 1. So follows similar rules to what you were using for your cycloalkanes. Just remember, this is not, oh man, this is not cyclohexane. Cyclohexane has a similar shape, and that it's 6 carbons, but it doesn't have the oscillating double bond in the center, okay? So now we're gonna build on the complexity here because organics get crazy large. If you've ever looked at, a medication or in food products and stuff, and they'll have like the molecule that you're dealing with, and it's always this really big, clunky, dramatic thing. Well, it's these sort of simpler structures tied together with a lot of these different types of accessories and bonds here. So we're going to look at alcohols, thiols. So I'm trying to get my pen to work here. Alcohols, thiols, ethers, aldehydes, and ketones. And so these are known as functional groups. A functional group meaning it's a group or a component within your carbon chain that gives it unique properties. So I would say the easiest one to understand is an alcohol. And an alcohol just has an OH sticking off of it. Okay, so you'll have some sort of carbon chain and there's an OH popped off of it. This is known as a hydroxyl group. The carbon chain could be as simple as 1 carbon, like in methanol, or it could be, a very, very long carbon chain, or it could be a carbon chain that has other accessories in it as well. This is the simplest alcohol. It's a single carbon with one of the hydrogens replaced with an OH. We have another thing called phenol, which is sort of like an alcohol, but it is an OH group attached to a benzene ring. Okay, so this is just the name phenol. This is very, very common. The reason why it gets its own name, why the benzene with its OH gets its own particular name, is because it is just so common in a lot of the products that we use. We have it's got thiol and ether flip-flopped, but an ether, and we will go over each of these, okay, and how to name them and everything, but we have an ether. An ether is when you have a carbon chain that's interrupted in the middle of the chain by an oxygen, okay, and then it will continue on with a secondary carbon chain. I remember this by ether or, so there's, either a carbon chain here or a carbon chain here. And then the oxygen in the middle sort of stops or truncates it. We don't think about it as one continuous carbon chain. We sort of think about this is one carbon chain and this is one carbon chain, especially when we're naming them, and we'll go into more detail. A thiol contains an SH group. Okay, so here we've got an SH off of this 2 carbon chain. So when naming alcohols in the IUPAC system, replace the E at the end with OL. If we can also have common names. With common names, they use the name of the alkyl group followed by alcohol. I'm not testing you on common names, okay? So don't stress too much about that. This is where I want you to be. So if I've got this thing right here, traditionally a carbon with 4 hydrogens, we would call that methane, right? 1 carbon, methane, all single bonded. If one of those hydrogens came off and instead it had an OH group, we would call this methanol. We take the E from the methane and we strip it and we replace it with OL, methanol, and we're done. What if we had a 2 carbon chain? Okay, this thing right here is known as ethane. That's not revolutionary, that's basic organics from last chapter. But if we happen to remove one of the hydrogens and there was an OH sitting at the end of it, I would call it ethanol, OL. The OL is telling you that there is an OH group. So when naming alcohols, name the longest carbon chain attached to the OH group by replacing the E with the corresponding alkane name with OL. Name aromatic alcohols as phenol. Okay, so if you have that benzene ring with the OH, just call that thing phenol. Number the chain starting at the end nearest the OH group. So remember when we had talked about priorities and certain things being more important, right? So a double bond is more important than an accessory or like a branch. OH is more important than a double bond. All right, so it being an alcohol will take priority over there being a double bond or a triple bond. So make sure you number the longest chain with the OH group closest to the OH. And let me actually, if you're wondering, well, what is this priority? How does that work? I don't think I have one embedded in the Moodle slides, but you can look them up pretty easily. So let's go with type in something like organic naming priority. And there's all sorts of images that will show you like what is the least important to the most important. Okay, so if we look here, an alkyl or a halide, so like Cl or F or something like that, those are down at the bottom. Then we can see an alkane, alkyne, alkene, amine, which we haven't gone over. Here's alcohol. You see how alcohol sits higher on the priority list? These are more important, take more precedent over the things lower down here. So alcohol is higher than these. you'll see ketone and aldehyde, which we'll talk about in a little bit, have a higher priority. The highest priority on this list is a carboxylic acid group, which again, we'll talk about a little later. But for now, just so you can see here that there is an ordering, there is a method to this madness. So alcohol will take precedent over a double bond. So if we're looking at this and we want to name this thing, we want to find first the longest carbon chain that contains the OH group. Okay, so I mean, for this one, it's this right here. Okay, it is 1, 2, 3, 4, 5, 6 carbons. So that's hex. They're all single bonded, hexane. But because there's an alcohol, I need to change this hexanol. Now with methane and ethane, there's only 2 carbons in the chain. So the alcohol doesn't have to be, you don't have to say where the alcohol is. Once you get farther out than 2, so 3 or more carbon chains, you have to explicitly say where the OH is. So we need to number this. Again, number it so that the OH falls on the lowest number. So 1, 2, 3, 4, 5, and 6. The OH falls on the 2. So this is 2-hexanol. Now, does this thing here encompass the whole structure? No, we're still missing this little accessory, and that makes a difference. So we have to write that in, and you just tack that into the front like you've done thus far. So we've got a methyl group on the 5. So this is going to be 5-methyl-2-hexanol. If you had more accessories, you would just keep piling them on in front. So 5-methyl, 2-hexanol. Okay. So I want you to name these 2 guys here. All right, so this first one is similar to that last one that we did. The difference being the chain isn't quite as long, right? So 1, 2, 3, 4, 5. I mean, you could have counted 1, 2, 3, 4, 5 as well. You could have gone this way. We'll just go straight across. So 5 is pentane. I'm going to drop the E and put OL, pentanol. And again, it's on carbon 1, 2. It's on carbon 2, so 2-pentanol. And then I've got an accessory of a methyl on the 1, 2, 3, 4. So 4-methyl dash 2-pentanol. So it's kind of like the last structure, just with one of the carbons missing in the chain. This here is phenol. Okay, the phenol will encompass all of this. So this you can kind of check off with the phenol. We still have to express the bromine accessory. So I need to count the carbons from OH in an order where bromine will fall on the lowest number. So 1, 2, 3. I'll go to the left. If I went to the right, it would put it at 1, 2, 3, 4, 5, too high. So this is 3-bromo phenol. Remember, if you have two words next to each other, you can smush them together. Okay. I'm going to have you do one going in the other direction. The slides don't give us one, but I want you to draw the structure for, oh, let's see, what do I want to do here? Okay, 4-4, let me put a dash in there. 4,4-methyl dash 3-oct. Oh, my brain. Let's add a C in there. Octanol. I was looking at that like there are not enough letters in there. There we go. 4,4-methyl 3-octanol. So draw the structure for that. On a test, you're not going to be drawing these things, but you'll be identifying them. So you want to be able to like look at the, 4 different drawings and pick out which one would make sense for this. So I'll give you a minute or two for this. So when working on this, again, I always start kind of from the right and work my way back. Octanol means that there's 8 carbons with an OH on the 3rd carbon. So C, this 3rd carbon will have an OH. Doesn't really matter if you put it up or down. C. 1, 2, 3, 4, 5, 6, 7, 8. I've got 2 methyl groups coming off of the 4. So 1, 2, 3, 4. So I'll put a CH3 here and a CH3 here. And then the last thing is just to saturate it with hydrogens where you can. So this is going to get 3 hydrogens. This is going to get 2 hydrogens. This will only have 1 hydrogen, just 1 open spot. This will get no hydrogens, no open spots, all 4 bonds. This gets 2, 2, 2, and 3, and we're done. I find that way, for me personally, I find that way easier because it's sort of laid out for you. You just gotta work from right to left. Okay, so that's alcohols, at least naming them. So how can you get alcohols? One way that you can get an alcohol is you take some sort of alkene, so ENE, which means that it has a double bond, and you hydrate it, not hydrogenate it, hydrate it, which means you add water. And what will happen is this double bond will open up, and you want to start thinking about water with alcohols as sometimes they'll even write it as OHH. So there's an OH and an H. The H gets plopped onto one of these, and the OH will get plopped onto the other one, right? And then you lose the double bond. That's what's happening here. So this one got an additional, except it's flipped in this one. This one got the additional hydrogen. This one got the OH on it. And you end up with an alcohol. So when you take any sort of alkene or double bond, not just ethene, it could be pentene or octene, and you hydrate it, so you add water, you force water into it, you release the double bond, and you break the water into an OH and an H, and you stick it on the adjacent carbons. If you have more than one alcohol group, you will use a prefix. So this one here has 2 OH, or rather 3 OHs. 1, 2, 3. So this is, and there's 3 carbons. So we call this propane, and it's called triol, TRI for 3, okay, or triol. If it was 2, it would be diol, and it says where it is. So it says 1, 2, 3 dash propane triol. They don't cut the E when they're using the prefixes. I don't really test you on multiple OH groups, all right? For what you're gonna get in your exam, you will be good with just putting 1 OH in there, 1 alcohol. Okay, yeah, we can move on from here. So alcohols and phenols, these are all examples of a phenol. So let's see if we can find the phenol group. Remember, phenol is a benzene ring with an OH. Whoop. Going for that methyl. Here's the benzene with the OH, the benzene with the OH, and the benzene with the OH. So the molecules are starting to get kind of crazier, right? More complicated, but they're all just based off of these building blocks that we're putting together. So here's an OH group, and then it has an ether group, and then it has a carbon chain here with a double bond. Phenols in general, you find them a lot in spices or things that have aromatic qualities to them, so strong smells, tastes, odors. These all have their own specific names. I wouldn't expect you to have those memorized. There's vanillin, what you find in vanilla extract, and I wouldn't expect you to name this thing, okay, in any capacity. So don't forget about that. So the next group that we are going to talk about is a thiol, and there's like a stinky skunk there. Thiols contain sulfur, and if you've ever been near a sulfur pit or smelled a hunk of sulfur, it is really odorous, very stinky. So thiols, or things that have these SH groups off of them, often have disagreeable odors. Well, I guess that's in the eye of the beholder. You find them in cheeses, onion, garlic, and oysters. I actually like the smell of all of those things, but they do tend to be like pretty strong odors. They also add thiols to natural gas. So like in a lab setting, when you have the gas that you're using to light your Bunsen burner and it smells if it's leaking into the room, the natural gas itself actually is odorless. Same thing with gasoline, it's odorless. They add things to it to give it a smell. This here would be known as trans-2-butene-1 thiol. So we can see that there is butene, means that it's a 4-carbon chain, 1, 2, 3, 4. 2 letting us know that the double bond is on the second. Trans because the same Z's are on opposite sides, so the hydrogens are opposite side, the carbon chain is on opposite side for trans. And then 1 thiol because the thiol group is on the 1. So as far as naming, in this system, thiols are named by adding thiol to the alkane name of the longest carbon chain and then numbering it near the SH group. So remember we had methane, CH4. Well, if it's got an alcohol group, we would call it methanol. If instead of having an alcohol group, it had a thiol group, that SH, we would call it methane thiol. We don't strip the E though, okay? So keep the E in there. Here's ethane thiol, 2 carbons with a thiol. Here, once we start getting more than 2 carbon chains, you've got to specify where it is, right? So in this one, we've got butane, butane thiol, and the thiol is on the 2nd carbon. Follows very, very similar rules to alcohol, an alcohol group, but it's just an SH instead of an OH. So here we have methane thiol. We can find that in oysters and cheese. We've got 1 propane thiol, which is in onions. And then this one is a little more complicated. It's mixing an alkene with the thiol, but this is 2-propene-1-thiol. This guy is in garlic. So, and again, like, I'm not really gonna have you do things where you've got something with like a double bond and a thiol group in there, but just for your information, that's how you would name those. Okay, so an ether. Again, I call these my ether ores because it'll be like 1 carbon chain on one side, either that one or this carbon chain over here. So 2 carbon chains separated by an oxygen. Those carbon chains can be a couple different things. They could be an alkyl group, so they could be like methyl or propyl or octyl, right? Some sort of long chain. Or they could also be an aromatic ring. So you may see an oxygen with a single bond and an aromatic ring on each side. It has a bent structure like water, so it looks kind of like this. Okay, these are pointing down. It has a common name. Excuse me. Ooh, it has a common name that gives the alkyl names of the attached groups followed by ether. And this is the one that I will actually have you go with the common name. So when looking at this one, how you name it, you find the oxygen, you have an accessory, or they're not really accessories in this case because they're not coming off of a carbon chain, but you have 2 limbs. You want to name those limbs with a YL as its ending. So this is 1 carbon. So remember meth, but we're going to ill it, methyl and a methyl. Because there's 2 of them, we would call this dimethyl, and then we just add the word ether at the end. Dimethyl ether. What if those chains are a little bit more complicated? You just name them in alphabetical order. So let's say we have an oxygen here, bonded to 2 different carbon groups. This is a methyl group, and this is a propyl group. Propyl because it's 1, 2, 3 carbon chain. I would name the methyl first because M comes before P in the alphabet. So this thing would be called methyl propyl ether. A lot of ethers are used in anesthetics. So it causes a loss of sensation in your body. It can also cause a loss of consciousness. So it blocks signals in the brain for awareness. So this is what conks you out when you have to have surgery. Creates a sense of artificial sleep. These are some more complicated ones. We're not going to stress about that. Okay, so I want you to write the structures for these following things. So there's 2 alcohols and an ether. 3-pentanol, ethanol, and diethyl ether. I'll give you 3-4 minutes for that. Make sure to put all the hydrogens in too, so fill it up. All right, so for this first one, this thing here is an alcohol. Carbon chain is 5, and the alcohol's on the third. So C, C, C. Third has an OH. C, C. And we just want to fill it. There's no other accessories, so we'll fill it in with our hydrogens. 3 there, 2 there, just 1 here, 2 here, and 3 here. And we're done. Ethanol, much smaller thing, just 2 carbons with an OH on, doesn't matter because this could be carbon 1 or we could classify this as carbon 1. So let's just put it here. Then we need to add some hydrogens. This gets 2 and this will get 3. And you're done. Diethyl ether. So anytime I see that ether, it's an ether or, I just write my oxygen first in the center. I know that that's going to be bonded to 2 different things. In this case, diethyl means that there's 2 ethyl groups. An ethyl group is a 2 carbon chain. So carbon connected to a carbon and carbon connected to a carbon. If you drew it in a straight line, that's fine as well. All right. So sometimes you'll see it like this. Okay. Any questions on that, on naming those? Not too bad. If you know the system, right? If you know the system, you just follow it, you should be good. We do need to talk about some of the properties of alcohol. An alcohol containing sanitizer, oh my gosh, we've seen like so much of this in the last year, haven't we? The amount of ethanol is typically 60% volume to volume, but can be as high as 85%. Because alcohols are flammable, hand sanitizers are considered a fire hazard in the home. Okay, they had this whole thing in the beginning of the pandemic where they're like, make sure your hand sanitizer is over 63% or whatever, just so it was a higher concentration. So when we classify an alcohol, it's important to note how many alkyl groups are attached to the carbon bonded to the hydroxyl. Okay, what does that mean? So you want to find your alcohol, your OH, and go to the carbon it's attached to. All right, so this OH is attached to this carbon. This OH is attached to this carbon. And this OH is attached to this carbon here, right? So you go to that carbon and you see, hey, how many carbons is it attached to? How many alkyl groups is it attached to? If it's only attached to 1 carbon group, like this guy here, and it has 2 hydrogens, we would call this a primary alcohol. In general, primary alcohols happen at the end of a carbon chain. Okay, so you can see the carbon chain is here, and the alcohol is sitting at the end. That's a primary alcohol. If the carbon that the OH is attached to is itself attached to 2 other carbons, or it only has 1 hydrogen, we would say that this is a secondary alcohol. This happens when your OH is somewhere in the center of your carbon chain. You see how this is a 3 carbon chain and it's in the middle? The OH is somewhere in the middle. That is going to be our secondary alcohol. The tertiary alcohol is when you take your OH, go to its carbon that it's connected to and see how many carbon groups, if it is connected to 3 carbon groups. So it has, this carbon actually has no hydrogens attached to it. We would call that a tertiary alcohol. This happens when the OH is attached in the center of the carbon chain, and that carbon also has a alkyl accessory or an additional carbon branch. Why does that matter? It matters with its reactivity. So when the carbon attached to the OH has hydrogens, we can do things with it. We can play around with it because these hydrogens are kind of easy to rip off. When you have a carbon that doesn't have any hydrogens attached to it. We can't play around with it. It won't react. So more reactive, primary, less reactive, secondary, not reactive, tertiary. And we'll look at some examples of that. So first thing I want you to do, I want you to classify these as primary, secondary, or tertiary alcohols. It should really only take you another minute or so. So just deciding how many carbons are connected to the carbon that you are attached to as an OH. So for this first one here, we find our OH and we go down to its carbon. And then we're going to see how many carbons is it attached to. This carbon here is attached to a carbon over here and a carbon over here. So this is 2 carbons, or you can think of it as it has 1 hydrogen to mess around with. So this we would call a secondary. This one here, the OH is at the end of the carbon chain. Let's go to its carbon. So the OH's adjacent carbon is attached to only 1 other carbon. That makes this a primary alcohol. This carbon here has 2 hydrogens to mess around with. This one here, okay, here's my OH, go to its carbon. It's connected to 1, 2, 3 other carbons. That makes this a tertiary. Tertiary. This carbon here doesn't have any hydrogens to mess around with. So another property of alcohols is they are, because they contain that OH group, they can be soluble in water because that OH group is a polar group. Okay, and likes dissolve likes. So the OH group forms a hydrogen bonds with other alcohol molecules and also with water. It is dependent though on how long the carbon chain is. So if the carbon chain is really short, this OH is like packing a lot of bang for its buck. There's not a lot of carbon to get in the way of this OH's attraction to the water molecules. So you can kind of think of it as the polar OH and then this non-polar chain. If you have an alcohol that has 1 to 3 carbons, they are easily soluble in water. As that carbon chain gets longer, you get more of this long non-polar chain, which is insoluble in water, that will decrease the solubility. This thing isn't as effective as this chain gets longer. So 1 to 3, soluble in water. 4 carbons, slightly soluble. If you go 5 or greater, the non-polar carbon chain has outweighed the polar quality of the OH. So we go into an insoluble range. All right, moving on from hand sanitizer. Solubility of phenols in general, phenol, which is again the benzene ring with the OH sticking off of it, they're slightly soluble in water. So they will, this forms an equilibrium. That's why we've got the double arrow here. Some of the Phenols will react with an adjacent water molecule, and the H will move to the water to give us H3O, and the oxygen will remain. So we get left with this thing right here. So this we can actually consider phenol to be a weak acid. Because when we stick it in water, what are you left with? You get some of this H3O plus. So it has a slightly acidic quality to it. Because of that slightly acidic quality, this is was used as an antiseptic, so to clean surfaces. So really quickly, would you say that A is soluble in water or not soluble in water, just by looking at it? I would say not soluble, yeah, because it is longer than the 5 carbon chain cutoff. This is 1, 2, 3, 4, 5, 6, too long, too much non-polar stuff. How about B? Would we say polar or non-polar, or I'm sorry, soluble in water or non-soluble? I'd say definitely soluble. We're at 3 or under. It's going to easily dissolve. That OH has a lot of room to connect itself or attract itself to the water molecules. All right, so the next group that we are going to talk about, or the next section we're going to talk about, are aldehydes and ketones. So vanilla flavoring is prepared by taking vanilla beans and ethanol and water. This thing contains an aldehyde group. It also contains a couple other things, right? There's a phenol, there's an ether, and then this thing down here, do you see this carbon double bonded to an oxygen and single bonded to a hydrogen? This is the aldehyde group right here. So aldehydes, both aldehydes and ketones contain what's known as a carbonyl group. Right? It's just a matter of where they are in the chain that determines if it is in fact an aldehyde or a ketone. So a carbonyl group is a carbon that is double bonded to an oxygen. I've got a carbon double bonded to an oxygen. The oxygen will have 2 lone pairs of electrons. So the oxygen in general is very electronegative, lots of attraction to the electrons are much more attracted to the oxygen. So the oxygen generally has an overall negative charge and the carbon will have sort of a positive charge because all these electrons, even in this double bond, are sort of shifted to this. It has a strong dipole with a partial positive charge. That's what I said in the carbon and the oxygen. So this is sort of a sticky thing. It has this very polar quality to it. It will grab onto other things that are charged as well. How do you decide whether it's an aldehyde or a ketone? So you have your carbonyl group, right, which I just simply said was a carbon double bonded to an oxygen. If that is happening at the end of the chain, so you will have a carbon, there it is, double bonded to an oxygen, and then its other bond is to a hydrogen because it's a terminal carbon. This is known as an aldehyde. I remember this by saying al at the end. I have no idea why that stuck with me from college, but I still remember it. So aldehydes, al at the end. All right, a ketone is when you take this carbonyl group and it's somewhere in the center of the carbon chain. So here I've got that carbon double bonded to an oxygen, but because it's in the center of the chain, one of the open slots will go to another carbon here and the other open slot is attached to another carbon here. There is no hydrogen on a ketone. Why? Because all of the 4 open slots are taken, right? 2 with the oxygen and then 2 with the carbons. Oops. So aldehyde, al at the end, ketone somewhere in the center. One way that people remember a ketone too is look at this in the image here. You see how the carbon goes up and then kind of around the oxygen and then back down. Some people think it looks like a keyhole. Ketone, keyhole. Okay. There's all sorts of little weird mnemonics and things that people use to remember their organics. Sometimes an aldehyde group is written like this, CHO, just for like ease. So it may be written as, you know, a carbon attached to a carbon, a cap attached to a CHO. This is because it's at the end, right? So there's our aldehyde group. It's a carbon double bonded to an oxygen and single bonded to a hydrogen. You could also see it written like this in a very, very basic skeletal structure. You'll see here's our carbon. It's double bonded to an oxygen and single bonded to a hydrogen. A ketone, you may see written as C double bonded to an O, or sometimes it's just written as CO. This is not carbon monoxide. This is for organics. They don't always write the double bonded. It's just assumed that the carbon is double bonded to the oxygen. Why? Well, there's a bond here on this carbon, there's a bond here on this carbon, and there's no hydrogen. So I have 2 open slots. I know that it has to be double bonded to the oxygen. Sometimes you'll see it written like this. Again, there's that sort of ketone shape or keyhole shape. So aldehydes at the end, ketones in the middle of the chain. How we name aldehydes. So there's an IUPAC system where we take the E off and we change it for AL. And it has its own names for the first 4 carbons. So if you have 1 carbon, it's not meth, it's form. And you go with formaldehyde. Or sorry, this is the common name. So we'll go back to the IUPAC. But the common names, if it's 1 carbon, we call it formaldehyde. 2 carbons, so acetaldehyde. 3 propano, 4 butyr. I'm going to stick you guys with the IUPAC. So with the IUPAC system, if it's an alkane, so all single carbons, this is for, again, aldehyde, you take the E off and you replace it with AL. There's Al. There's Al. Do you need to say where the aldehyde is? No, because remember, where is an aldehyde always? Al at the end. It's always going to be on carbon 1. So here's a single carbon. And there is the double bond. And then there's the hydrogen. Right? We call this methanal. This is also commonly known as formaldehyde. If we have a 2 carbon chain, ethanal, Al. 3 carbon chain, al at the end, propanol. 4 carbon chain, usually this is like our cutoff, right? Where if we have like 3 or more, we have to start numbering where these accessory or not, where these functional groups are. But I don't have to do it for aldehydes. Here's a 4 carbon chain. There is my aldehyde group. It's always going to be at the end. So I don't need to say 1 butanol because it's always going to be on carbon 1. So name the longest carbon chain by replacing the E in the alkane name with Al. Name and number any constituent substituents. So you may have to add accessories. If you do name accessories, you always count from the carbonyl group. So you count from the aldehyde side because it is the highest priority. So looking at this thing right here, let's name this thing. So you first want to identify where the aldehyde group is. So the aldehyde is over here, Al at the end. We need to count how many we have. So our carbon chain here is 1, 2, 3, 4, 5. So this is pentane. I take off the E and I replace it with Al, pentanol. Again, I don't need to call it 1 pentanol because if it's Al, it's at the end. But I do need to number these based off of the carbonyl group, 1, 2, 3, 4, 5, because I have an accessory here. I have a methyl group on the second. So 2-methyl pentanol. This set of slides goes through that whole process. So there's our pentanol. And then we just need to number the accessory. Again, don't number based off of creating the lowest number for your accessory or your substituents. Always number from the aldehyde side. Good with that? Just another thing to add to the list, right? So you want to be on the lookout for when you start seeing that double bonded to a carbon, that is going to be either an aldehyde or a ketone. Okay, I'll blow through this. So let's name ketones. So when naming a ketone in the IUPAC system, you take the E and you replace it with ONE, like the ending of ketone. Ketones, you do have to specify where they are in the chain if the chain starts getting longer than 5 or 5 or longer. Okay, so this one here, well, if it's a ketone, it has to be in the middle. That is what makes it a ketone. So if you only have 3 carbons, the ketone's got to sit in the middle. So I can just call this propanone. This is also known as acetone. If I've got 4 carbons, again, the ketone has to sit in the middle somewhere. But I know that there's only 2 places. It could be here or here, which makes it on carbon 2 in either one. So even the 4, you don't have to number it. You would just call this butanone. But when we get to 5 or more, the ketone could be in the very center, or it could be on one of these secondary carbons. So you have to call this thing 3-pentanone. And then obviously, as you get longer than 5, you always have to be telling the reader where is that ketone. The everyday names you can see here, sometimes they call them dimethyl ketone, ethyl methyl ketone, diethyl ketone. The way they do that, they take the carbon and the oxygen and they clump it together, and then they consider these the limbs. So this is where the dimethyl, a methyl and a methyl. I will be testing you on the IUPAC system. What if you have this thing here? This is, if you have a hexene or a hexane ring, so 6, and it's double bonded to an oxygen, this is known as cyclohexanone. It's a cyclical ring of 6 with a ketone sticking off of it. But you do need to add the accessory. So 1, 2, 3, this would be 3-methylhexanone for this guy. So you may see ketones on some sort of ring as well. So when naming ketones, name the longest carbon chain, replace the E with ONE, number the carbon chain starting from the end nearest the carbonyl group, again, because that takes the precedence, and indicate its location, and then name and number any of the substituents. So I want you to name this thing here. It is a ketone. Okay, so first we want to find the longest carbon chain that has the carbonyl group in it, and that is 1, 2, 3, 4, 5. 5 carbons, that's pentane, but we've got this carbonyl group, so we need to call specifically a carbonyl group in the center of the chain, so this is a ketone. So we've got pentanone. Now, if it's 5 or more, I do need to classify the location of the carbonyl group because it could have been on the second or it could have been on the third. There is no fourth because I would have just then counted it from this side. So we want to say that this is 2-pentanone. That takes up everything but the methyl group, right? I still have this little accessory here. So that's on carbon 1, 2, 3, 4. So 4-methyl -2-pentanone. Pop through the slides here. Pentanone, it's on the 2, and then we've got the methyl on the 4. So you're going to want to be able to start identifying these functional groups. As far as aldehydes and ketones in water, they are very soluble in water when you again have 4 or fewer carbons, but not but they're not that diminishes as the group gets longer. So for our either our ketones or our here I've got my aldehydes. So the first 4 are going to be very soluble. Here's butanone, also very soluble. When we start to get greater than 6 is sort of the cutoff, we lose that solubility because again, what is making it soluble in water is this thing, right? These polar-like qualities. This thing is here, this thing is here. These are the things that give it a polar component. But when you start to have so much non-polar stuff, it kind of covers up or blocks that polar component, so it can no longer dissolve. Important aldehydes and ketones. So acetone is a solvent that we use all the time, really. I mean, if you use nail polish remover or if you use paint remover, cleaning fluids, it contains some quality of acetone in it. They also put acetone in, sometimes they put it in like skincare products and things like that to like allow the products to evaporate. So it's not like greasy on your face. It has a very drying quality though, so I wouldn't recommend putting products on that contain acetone. Over on the right, we have the simplest of the aldehydes, formaldehyde, and that is what you think of when you think of the liquid that preserves. So looking at these, just go ahead and classify them as an aldehyde or a ketone. You don't have to name them, just classify, say that's an al at the end or that's a ketone in the middle. Should take 20 seconds. Okay, A here. So there's our carbonyl group and it is attached to 2 other carbons on both sides. So we're gonna say that this is a ketone somewhere in the center of the chain. This one here, we've got carbon, there's our carbonyl group and it's attached to a hydrogen on one of those sides. So this is an aldehyde, al at the end. Over here, we've got a bunch of fun stuff going on, but this is what we're really looking for. There's our carbonyl group and it's at the end. So this is an aldehyde. This one here is sitting in the middle of the chain, right? You're always, if you're like coming off of a cyclical structure, you're always in the middle of the chain. There are always going to be 2 carbons on either side. So this we would say is a ketone. Got 1 more minute. See if you can name these real fast. They're both ketones. Sorry. Sorry. Give you 20 seconds so that I can give you the answers, so that I respect your time as far as lecture. Okay, so this top guy, there's a ketone. How long is the carbon chain? 1, 2, 3, 4, 5, 6. So hexanone, and the group is on the second, right? 1, 2, so 2 hexanone, no accessories, that's it. Second one, 1, 2, 3, 4. This is not a carbon, this is a chlorine. So 4, so that's butane. It's on the second, but it doesn't matter if it's got 4 because it's either going to be here or here. It'll be on the second in either situation. So we're going to call this butanone. We're going to number closest to the carbonyl group. So this is 1, 2, 3, and 4. So there's a chlorine on the fourth. So it's 4-chloro butanone. Hexanone, easy for the first one. The second one, we have to do a little bit more. I don't know why they put a 2 there. You don't need to put a 2 there. 4-chloro, it should just be 4-chlorobutanone. But they wanted to put a 2 there. It's either going to be here or here, so it's always on a 2. Sometimes you will see differences in the way that these are written, even if you do like practice online and stuff like that. So I guess for the sake of if you're doing the homework, go with, if you fall across something that is very, very similar to this, you can add the 2. It won't hurt you. Okay, so we are going to stop there. Next time we'll talk about reactions of alcohols, thiols, and aldehydes. They do very consistent things when they get into certain situations. And we can do some more practice with naming all this stuff. I'll kind of jumble them all together and you'll have to pick out, is it an alcohol, a ketone, an ether, or whatever. So enjoy the rest of your day. General questions, shout them out. Personal questions, hang around, and I will see you on Thursday. Thank you. Natalie, will the previous lectures that correlate with the upcoming exam post before we need test? They should, yeah. Is last week's not up, Natalie? Is last week's lectures not up?
The last time I checked, which I think was on Sunday, it was, the most updated was 308.
Oh no. 308?
Yeah. That was either Sunday or yesterday that I checked. And I don't know if it's something wrong on my end. I don't know.
Okay, yeah, that's not good. Let's see, 308, that's back in May. We should definitely have lectures. I've been having issues with YouTube, but let me see. Yeah, because you definitely obviously want the lectures up if you're yeah, it looks like 338. Oh no, 315, 316, 324. I'm seeing more recent ones than that. Nice. Hold on. My screen. The most recent one that I have up on there is 325.
Okay.
So looks like I need to put up last week's. Because we had spring break. So
Okay.
that was the first week. Yeah, so I've got to put up last week's and then this week's. So I will do that right now.
Awesome. Thank you very much.
Cool. Thanks, Natalie.
No problem. Have a good day.
You too. Bye. Hey, Miley, do you have a question?